This is an interesting one, and this is count non-decreasing subarrays after key operations. So basically, we're given an array of n integers and an integer key, and we are told that we can have different subarrays, and for every subarray, we can use this many operations. So all the subarray operations are independent. So I can take this as a subarray or this as a subarray and use k equal to 7 number of operations for either of the subarray. So I'm not going to exhaust uh, k value operations across different subarrays, right? So that's there's that. The next thing is what we need to achieve by using this operation is we can take any value in the subarray, use this operation and increment any value in that subarray by 1 so that I end up getting a uh, non-decreasing order in that subarray by using not more than key operations. So we need to find all such subarrays. We need to find the count of all such subarrays. So the brute force is not going to work here. We have high constraints. What we can do is we can see that if I start from 6, I can use 6 3 as well, because I am going to write make it increasing so that I make it non-decreasing. So 3, I need to use 3 operations to make it 6. At least 6 I need so that it's non-decreasing. So for this subarray, this is valid. Can I go further? For 1, I need to make it again 6. Can I make it 6? I've already done 3 operations. So 3 plus 6 will be greater than k. So no, not possible. So if this is not possible, then this is not going to be possible, right? If the smaller subarray is not possible, the bigger subarray using that same starting element is also not possible. So I need to go here. I can do this by using 2 operations. So I make it 3 3. Again, one more operation. So I can make it 3 operations and make this subarray valid. This one will already be valid because 4 is greater than 3. I have made these 3 elements 3. So 4 is already greater than 3. So this is valid. Now finally, this is also valid since 4 and 4 are equal. And we got something right here, right? So this entire subarray is valid, and all the smaller subarrays in this big subarray is also valid. So 1 2 is also valid, 1 2 4 is also valid. So we see some kind of a sliding window technique here. So that's first intuition. Second intuition is make array non-decreasing, right? So if I did it this way, what if I did it this way? So if I start from here, 4 4 2 1, right? So here I'm making it increasing. So here I'm making it, from here I'll be making it decreasing 4, and then I want some smaller value or equal. This is good. This is also good. I need to not use any operations till now. This is still good. This is bad. So I need to use operations now. So if I have 3, then I need the past values that have been used up, right? So I can have something like a container where we have 4 and then 4 and then 2 and then 1 and then 3. So by the time I have 3, I will check the top value of that container. I don't know what data structure, but that container can be something that gives me the top value. So I remove that top value and increase the count of how many 3 I have right now, right? So I will have two threes now, and I will use some operations. So I will have operations track as well. So now the data structure is already known here. I'm referring to stack. So I can have something like a sliding window where I start from here. Let's do a dry run. All right, I'm going to have an answer initially 0. Operations needs to be tracked for a particular window. How many operations has been used? Stack is needed initially empty. I will be here and I can expand this window. So right here I see 4. I am not using any operation. This is a length of one subarray which is valid on its own. So I'm going to increase my answer by 1. Operations is 0. Stack contains 4 and its number of count is 1. Right? I have single 4. I increase the window size. I see 4. I'm going to see the last element, the top element. I see 4 comma 1. Right? I'm going to increase the count. That's it. Or probably I can do something like, if the top element is not uh, if it's smaller than the element that I have encountered, the new element that I've encountered, or if it's equal, then I'm going to pop this. I'm going to keep count of the number of pops that I've made, and then I'm going to push this with that pop count plus 1. Right? That is also possible. So we have different implementations. I'm going to use the one that suits me. So 4 comma 2 will be the next thing, right? Still 0 operations used. Length is 2, so I'm going to add 2 to it, and I'm going to expand it. I see 2. This is still valid, right? So I can just push. So the top element is 4, that's greater than 2, so I can push 2. So this needs to be non-decreasing this way, right? From the bottom it needs to be non-decreasing. That's why I can push this with a count of 1. Still 0 operations used. Length is 3. Add that. Let's go further. I see 1. I'm going to still count this as valid. 1 comma 1. Add it to stack. Length is 4. Add it to answer. Finally 3. I need to pop some things. I'm going to pop 1 comma 1, and what's going to be the number of operations that needs to be included, implemented? That is going to be the top element value, or the new element value minus top element value into the number of count. That's the number of operations that I have used. So it's going to be 3 minus 1 into 1. So that's 2. 2 operations used, and this is popped. The next thing I see is 2 comma 1. Right now at hand, I should remember that I have 3 comma 2, right? I have two threes right now. These are the two threes. I see 2. Count is 1. And 3 is greater than 2. So I need to do something. I am going to increment the operation by 2 comma 3 into 1. Sorry, 2 minus 3 minus 2 into 1. That is just 1. So operations become 3 and count become 3, and that's it. Next I see 4. It's a greater value, so I can just push 3 comma 3. I have used 3 operations till now, and that is this. Next I see this one. So by the way, this is 5 length. Let's add 5. So total is 15 right now. Next I expand. On expanding, I see that one. On expanding, I see 6. I see 6 comma 1 needs to be pushed into stack. The top element is 3, and 6 minus 3 into 3 is 9. So I'm going to use 9 operations, right? And that's going to make it 12. It's greater than the k value that I've decided. The test case has decided, right? So that is not possible. So I can at least pop this and add 4 to it, because the count is 4 now. These are the 6's, and then I see 4 comma 2. I am going to add few operations, and that is 6 minus 4 into 2, that is 4. So I make it 6. I push this, I pop this, I push this. Alright, now it's time to reduce the window. I can't do anything further because the operations has gotten out of limit. I pop this, but I'm popping this. That means I'm losing or gaining all the operations that I have used for 4, and that is nothing but this bottommost value inside stack. Whatever the stack is going to contain at this point, the bottommost value is something that is that this value is going to be converted or was being converted, right? 4 was being converted to 6, and that's how operations right now has that many operations. So I'm going to lose 4. That means I'm going to reduce the count, and 4 comma 6 comma sorry 6 minus 4, two number of operations needs to be reduced. So right now operations was 12 plus 4 16 minus 2, right? 16 minus 2 is 14 operations, and this is the window. I'm going to do the same thing because operation is still out of limit. This is going to be 4 now, count, and this is going to be minus 2 again. So 12. I'm gaining the 2 operation that I was used here, right? Now I see 2, still operation is greater than whatever uh, it's greater than 7. So I am still going to have to reduce the window. So let's say this becomes 3. 6 minus 4 or 6 minus 2, that is 4, was the operation used for this particular value. I'm losing that, making it 8. This comes here, still greater than 7, making it 2. 6 minus 1, that is 7. Sorry, 6 minus 1 is 5. 8 minus 5 is 3. So I, I, I am here. Operations is now valid. What is the length? Length is 2, and that's it. That's our answer. Because I can't further stretch I, it goes out of bound, and I end up having 15 plus 2, 17 as my answer. So what we did is, in stack I want the bottommost value, and I'm updating its count. So instead of stack I should use a deck, since I am doing both front operations and the back operation, right? So I can use deck. So pretty long explanation. Let's have a things to do list here. Things to do. So I'm having a sliding window, right? I'm having a left pointer and a right pointer. So let's have a move left pointer action. Here I am checking if the top element value is less than equal to the new element value. In that case, I am popping and I am keeping count of the number of pops that I've made. So I can have a int pop count. Here I'm checking. Basically, I'm popping things and incrementing the operations, right? So for every pop, I am going to increment the operations by new element value minus the top element value into count, whatever count we have. So we have in deck the count as well. Next thing we are doing is a push. Push is using the element value or the new element value, comma, pop count plus 1. Plus 1 is because the new element itself is a value and the number of pops that I've made. The last thing is moving the right pointer towards left. So this is yeah, moving the right pointer. Let's do that. So for moving the right moving the right pointer, I'm reducing the operations, reducing operation by the new element value, right? The new element value, I'm reducing this window by using the new element value minus the bottommost value inside the deck. Bottom, actually not the new element value, but the element value that I'm losing. That's the one that I'm subtracting it with. So the losing element minus the bottom, the one that it was converted to. So this is going to be the bigger value. So let's have other way. Uh, yeah, the bottom deck value, right? Also reduce count and push back from the backside, push it inside. So I'm updating the deck from the backside and I'm pushing it only if the count is greater than 0. If it's not, then I'm not going to push it, right? So these are the things we need to do. Let's do that. So let's have a long answer firstly. All right, let's have a deck. Deck is going to have a pair for the value and the count. Get the n of the size inside n variable. J and I is going to start from n minus 1. And I is also going to start from j. While I is greater than equal to 0, I'm going to, because at this point I is greater than equal to 0, I try to make it 1 less. I go out of bound. I don't do anything. The new element that I was talking about here is this nums of I, because my window size is going this way. Usually the window, the new element is nums of 0, j, right? but this is growing backwards, this window. Also, I'm going keeping track of the pop count right here. So I'm doing the left pointer part first while the deck is not empty, and the deck dot top value, that is front dot first. Let me use a vector of int. Usually I go for vector of int because I don't like first and second. So this is less than equal to the new element. In that case, I'm going to pop, but before popping, let's increment operations. Let's have operations. Uh, let's have long operations because this can overflow. So initially starting with 0, let's have operations plus equal to new element. So operations is going to incremented by this value, new element minus the top element. New element minus dq dot front 0 into count. Alright, and pop count is going to be incremented by the count value of that top value inside deck. So deck front 1, right? And I'm going to pop from the top, that is front, pop front, at least in C++. Now I am going to push inside the deck from the front side, making it with a value new element, comma pop count plus 1. Alright, now the deck, sorry, this is push front, so this is good. At this point, I have stretched the window from this point ij till this point, right? Uh, yeah, I mean, I have used the new value and pushed it inside deck. So I'm stretching it right now. At this point, I can check if the operations is still less than equal to k. If it is, then whatever the length of the window size is right now, I'm going to increment that much. So that is nothing but j minus I plus 1. This can go out from an overflow, so 1 LL, let's multiply it. Else, if that is not the case, I'm going to reduce the right pointer and do that until I is while I is still less than j and operations is still greater than k. That many time I'm going to reduce the right pointer. So I'm going to reduce the right pointer. Every time I reduce, I'm going to increment or reduce the operations value as well using the bottom deck value. That is nothing but, let's get the bottom deck values. That is element bottom value, comma bottom count is equal to deck dot back. Operations is going to be reduced by what value? By bottom value, that is the bigger value, minus the new value, that is nums of j. I mean the one that is losing, that I'm losing, that is nums of j. All right. Uh, Yeah, I guess this is good. Let's lose that deck value from the bottom, and if count minus one, that I've won, the one that I've lost is this one, num_g. If it's still greater than 0, then I'm going to push back the popped value with a different count, that is uh, bottom value comma count minus 1. This is good. Every time I do that, I'm going to reduce the right pointer, and at this point, if I'm out of this loop, that means operations are still valid. That means I can uh, increment the answer using the length of the window size, and finally at this point I can stretch, right? So I minus 1 is needed. Alright, so we are good here. We can return answer here. Let's see, this was a long code. Let's see if this works. Of course, operations. Deck dot front of 0. So this is a function. Okay. So there is nothing called count, and that is my mistake. So count, let's get that here. Let's see now. Okay, deck dot back is going to give me a vector. So instead of doing it this way, let's do it this way. Let's see now. This works out. We are good. Right. I forgot that this is C++ and we can't really have a deck of vector. This is just C++. So pair of int and int is what we are going with. Here I need to update a bunch of things. Deck dot first, deck dot not first but second. Alright, this is going to be again deck dot first. This is going to be, let's not have the count here. I'm not really having a benefit with it. Let's have deck dot front of 2 or 1, and finally sorry, this is dot second and this is dot second, and lastly here we have some problems. Let's go with the previous implementation of bottom value count in just a single line will do the job. Deck dot back. Alright, I think we are good. Let's see if this works. Okay, there is some mistake. I have bottom count instead of count. This is bottom count minus 1. Alright, let's see. Let's see now. Okay, this is going overflow. So this is overflowing. So 1 LL, let's multiply it. Let's see now. This is O of N sliding window, and we have a deck, so we have O of n in the space as well. All right, this works. That's the fourth problem. Thanks.